Okay, so lesson number 6 is numerators become ratios when denominators the same. So what does that mean? For example, if you have a question that is saying 1/3 to 2/3, then the ratio becomes 1 to 2. So in other words, once the denominators are the same, the numerators can be put into a ratio as follows. So, for example, if you have 5/7 to 6/7, then the ratio becomes 5 to 6. Or if you have 2/5 to 3/5, the ratio becomes 2 to 3. Because the denominators are the same, we can make the numerators as a ratio. So here we have denominators that are different. So are we still able to use the numerators as a ratio? For example, are we still able to write 4 to 9? And the answer is no, we can't. We need to first make the denominators the same. So I need to start again. Now, I can simply times 5 or multiply the number 5 by 20 to make the denominators the same. But as we know with adding fractions, we need to find the lowest common multiple. That means that we need to find the first multiples that the multiples of 5 and the multiples of 20 share. And the reason why we do that is because it's a lot easier to simplify when we have the lowest common multiple as a denominator. So let's do that. Instead of multiplying 5 by 20, let's look at the multiples of 5 and let's look at the multiples of 20 and circle that number that they both share, the first multiple that they both share. So let's go to the multiples of 20 first. Okay, so if we look at the multiples of 20, we can see that there is a 20 over here. 20 times 1 is 20. So let's circle that. I know right away that 20 will be in the multiples of 5 because it ends in 0. As you know, the multiples of 5, the second number, the alternate number, will always end in a 0, as you can see there. So as I go along the multiples of 5, I can see that there's a number 20 there as well. So I'm going to circle the number 20. So as you can see here, the first multiple that they share is the multiple of 20. Okay? So now I know that the denominator for both fractions now should be 20. So let's write that down. Okay. So now the next question is to ask ourselves, what did we multiply 5 to get to 20? Well, if we have a look at what we circled here, we'll see that 5 multiplied by 4 equals 20. So then I just simply write down here, multiply that by 4. And we know that whatever we do to the bottom one, to the denominator, we also do to the numerator. So we also times the top by the number 4 as well. Okay, now what about the number 20. What did we multiply 20 by to get to the number 20? Well, again, we look at our times table, we'll see that 20 multiplied by 1 equals 20. So we write that down as well. So 20 times 1, and whatever we do to the denominator, we do to the numerator. So let's times that by 1 as well. Okay, so now the rest is pretty easy. 4 times 4 equals 16, and 9 times 1 equals 9. Okay, so now we have the same denominator. Now we can use the numerators as a ratio. So now this statement here, we can convert that to a ratio by using the numerators because the denominator is the same. So that means that our final answer will be 16 to 9. Okay, so what about this question here? How do we convert this to a ratio? We'll notice that the denominator for both the mixed number and the fraction is the same. We've got 3 here and 3 there. So are we then able to write down 2 to 1? And the answer is no, we can't. We need to convert the mixed number to a improper fraction before we can use the numerators as a ratio. Okay, so let's do that. Let's make this mixed number into a improper fraction, and we know that we get the denominator, we times it by the whole number, and then we plus it to the numerator. So that means that the answer will be 3 times 1 is 3 plus 2 is 5. So 5 over 3 to 1 over 3. Okay, so now we have the same denominator still. We got rid of the whole number. Now we've got the numerator updated. So now we are able to use the numerators as a ratio. So now we can go ahead and write it as 5 to 1. Okay, so to convert these two fractions to a ratio, we need to convert the mixed numbers into improper fractions. Again, we know what to do. We times the denominator with the whole number, and then we plus that result to the numerator, and we do the same thing for the other one. We multiply the denominator with the whole number, and then we add that result to the numerator. So let's go ahead and do that. We have 3 times 3 is 9 plus 1 equals 10. And we keep the denominator the same. And we do the same on the other side. 2 times 2 is 4 plus 1 is 5. Okay. So, can we now use these numerators as a ratio? No, because we have different denominators here. So we need to change these denominators so that they're the same. So what do? We need to find that common multiple that the multiples of 3 and the multiples of 2 share. And if you have a look at our times table, we can see that the multiples of 2 has a number 6, and the multiples of 3 has a number 6 as well. So the lowest common multiple for these two factors is the number 6. So now we can say that the denominator that they share is number 6. Now, we multiplied 3 by 2 to get the 6. So we write that down, and whatever we do to the bottom one, we do to the top. And 10 times 2 is 20. So we're halfway there. So now we go to the other side. We multiply 2 by 3 to get the 6. So we write that down. And then whatever we do to the bottom one, we do to the top. 5 times 3 equals 15. Okay, so now we have the denominators the same. Now we can use these numerators as a ratio. So let's do that. 20 to 15. Okay, so can we simplify these numbers here? What's the highest common factor? Again, we look at our times table and we find, well, we try and find the one row or the column that has both these numbers in it. So we do that and we can see that there is a number 15 and a number 20 in the multiples of 5. That means that the number 5 will go into the 15 and the 20 equally. So we divide both sides by 5. So 20 divided by 5 equals 4. And 15 divided by 5 equals 3. So your final answer should be 4 to 3.